Welcome to nuclear chemistry. When we did symbols like this, which show that we have 8 protons and 10 neutrons, or this one, still oxygen, but with a different number of neutrons, using these isotope symbols, is very important in nuclear chemistry because one is going to be stable and one will be radioactive. And so you need to be working with the right isotope. So we have thermodynamic stability and we have kinetic stability. And kinetic stability, the probability that the nucleus will decompose to another nucleus, is the radioactive decay. Now, when you look on the periodic table, everything with 84 or more protons is unstable. Smaller elements have stable and unstable isotopes. So if you look at my oxygen example, 8 protons, 8 neutrons, that is the stable one because the lighter nuclides have a neutron to proton ratio of 1 for being stable. The heavier it gets, the more neutrons it needs. So if you look, this red line there is the 1-to-1 ratio, and the red dots are the stable nuclei. And so you can see we start off at a 1-to-1 ratio, and then we go more to 1.5 neutrons for every 1 proton being the stable ratio. Now, even numbers of protons or neutrons give more stability. There are certain numbers of protons or neutrons that are especially stable. And while this is observed, there's not a concrete explanation as to why, but we have an analogy. It's like we have a certain number of electrons make things more stable, noble gases. Those half-filled shells were more stable than the in-between. So we have other instances of where certain numbers have given us certain stability.